Subscribe our channel, press the bell icon for latest videos.
Hi friends, here in this video we are going to see the effect of reactive gyroscopic couple on an airplane. For that the condition is given. Let's get started. Now the condition is when the propeller rotates in anti-clockwise direction. So this is the propeller of the plane. The axis about which it is rotating is the spin axis. Here is the observer, so we have to take the reference of the observer. That is, we are looking the plane from the front, and while looking from the front, this axis is called as the spin axis. The propeller is turning in an anti-clockwise direction. So here is the anti-clockwise direction, and now when the anti-clockwise direction is shown here, this rotation indicates the angular velocity of the propeller denoted by omega. So now I would be denoting omega, which is a velocity, angular velocity, with a vector, and that vector would be in the direction looking from the front, that is the spin axis. This is rotating in an anti-clockwise direction. So curl the right hand fingers along the direction of the propeller. So propeller is rotating anti-clockwise, and here I am curling the fingers in the direction of the propeller in an anti-clockwise manner, and this thumb, the right thumb, it indicates the velocity vector. So the velocity vector is towards the observer, denoted by omega. Then after that there is another axis, which is the vertical axis, about which the plane is taking the turn, and that turn is left turn. This axis is called as recession axis. And for the plane taking the left turn, we have to imagine that we are sitting into the plane, not observing the plane from outside. This observer is there only for the spin axis, but whereas when the plane is taking a turn, we have to imagine that we are sitting into the plane and then it is taking a left turn. So the left turn would be along this direction. Now when the plane is taking a left turn, it is rotating about the vertical axis, which is the precession axis, along this direction. Now this direction indicates the velocity of precession, angular velocity of precession. Now to get the vector of this precessional velocity, I have to turn this spin axis by 90 degree in the direction corresponding to this rotation. Since this rotation from looking at the top, it is in an anti-clockwise direction, I have to turn this omega in an anti-clockwise direction by 90 degree in a plane. So this angle is 90 degree, and here I had turned this velocity vector by 90 degree. And why in this direction? Because since it is left turn and the precessional velocity is in this direction, which is anti-clockwise, so omega has been also tilted 90 degree anti-clockwise, corresponding to the precessional velocity. Now here this arrow which I have got, this indicates the active gyroscopic couple. Opposite to it would be the reactive gyroscopic couple. So this is the reactive gyroscopic couple. This vector indicates the direction. Now how to get the effect onto the plane? For that, match the right hand thumb with this arrow of reactive gyroscopic couple. So when I am matching this with the reactive gyroscopic couple, this thumb indicates the reactive gyroscopic couple vector and the curled fingers show the coupled direction, and this couple would be in this direction. And so here this is C indicates the reactive gyroscopic couple, shifting this couple similarly onto the plane. So like this direction, it has been shifted onto the plane. So when this plane is moving, the propeller is rotating in an anti-clockwise direction and the plane is taking a left turn. The effect is because of the reactive gyroscopic couple, the tail of the plane gets dipped or lowered, whereas the nose gets raised. So I'll write the effect. So due to the reactive gyroscopic couple, in this case, the tail is lowered and the nose is raised when the plane is taking a turn towards left. So that's about the reactive gyroscopic couple. And if you all find my videos helpful, you all can share, like, comment and subscribe our channel. Thanks a lot.